Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of game theory with engineering applications. We'll dive into key concepts like choice molecules, anatomy of choice, space of possibility. Let's get started. Slide 1. Choice molecules. Let's start by understanding the concept of choice molecules. In simple terms, a choice molecule represents a single decision point where a player must make a selection from multiple available options. This idea is critical in game theory because every choice shapes how the system evolves. 1. Definition. A choice molecule is the smallest decision unit in a system where a player selects from a set of options, leading to different outcomes. It helps us understand how individual decisions drive larger systems. 2. Components of a choice molecule, options, different paths or actions a player can take. Consequences, outcomes resulting from each option. Context, the environment or rules governing the choice. For example, in a chess game, deciding whether to move a pawn or a knight represents a choice molecule. 3. Significance. Understanding choice molecules is essential for designing interactive systems. It helps predict user behavior, optimize decision-making processes, and design more engaging games and simulations. 4. In engineering, choice molecules are applied in decision support systems to evaluate multiple scenarios and outcomes. Slide 2. Anatomy of choice. The anatomy of choice breaks down the structure of any decision into its key elements. This concept helps us analyze how and why decisions are made. 1. Options. These are the available alternatives a player can select. More options create complexity but also provide freedom. 2. Consequences. Each option leads to specific outcomes. Players consider how their choice affects the system. 3. Constraints. These are the rules and limitations restricting available options. For instance, in software systems, a user can only perform actions permitted by the interface. 4. Uncertainty. In many systems, outcomes are probabilistic rather than guaranteed, making choices more complex. 5. Information. The data available to the player affects decision making. Incomplete information increases uncertainty. 6. Utility. Each choice provides value or reward based on the player's objective. For example, a user might select an option that maximizes profit. 7. Agency. This reflects how much control a player has over decisions and outcomes. Example, in an online shopping system, a user choosing a product considers available brands, options, product quality, consequences, and budget limits, constraints. Significance. Breaking down choices into their anatomy helps engineers design better decision models by understanding the motivations behind user behavior. Slide 3. Space of possibility. The space of possibility represents all potential choices and outcomes available within a system. It maps out every path a player could take and how those paths affect the system. 1. Definition. The space of possibility is the complete range of decisions and consequences a player can encounter in a system. It defines what is possible and impossible within the system. 2. Boundaries. These are limits set by the system's design. For instance, a mobile app limits the user to predefined functionalities. 3. Pathways. Different sequences of choices led to various outcomes. 4. Complexity. As the space of possibility grows, decision-making becomes more challenging due to the increasing number of pathways. 5. Dynamic space. Some systems change their possibilities over time based on previous choices. 6. Exploration. Players explore the space by trying different options to discover all possible outcomes. 7. Design implication. Engineers must define clear boundaries and pathways to make systems usable and intuitive. Example, In a video game, the space of possibility includes every level a player can explore and every action they can take. Significance: understanding the space of possibility helps optimize decision flows, ensuring a balance between freedom and guidance in interactive systems. Slide 4. Differences between choice molecules and space of possibility. 1. Definition. Choice molecules, basic building blocks of decision making. Anatomy of choice, the internal process guiding how decisions are made. Space of possibility, the entire range of potential actions and outcomes. 2. Focus choice molecules, focuses on individual options and their immediate structure. Anatomy of choice, explores how decisions are formed and executed. Space of possibility, analyzes all possible actions and their outcomes. 3. Components. Choice molecules, includes options, consequences, and constraints. Anatomy of choice, involves decision points, criteria, and outcome evaluation. Space of possibility, covers breadth, depth, boundaries, and pathways. 4. Interaction choice molecules, focuses on immediate, individual decisions. Anatomy of choice, examines the process behind decision making. Space of possibility, considers all possibilities and how they evolve. 5. Complexity level. Choice molecules, low level, dealing with specific actions. Anatomy of choice, mid-level, analyzing the decision-making process. Space of possibility, high level, covering system-wide possibilities. 6. Example choice molecules, selecting between two encryption algorithms. Anatomy of choice, evaluating which algorithm meets security needs. Space of possibility, designing a system with varied encryption pathways. 7. Application. Choice molecules, used in automated systems and user decisions. Anatomy of choice, applied in engineering decision support systems. Space of possibility, critical for game design, AI, and adaptive systems. Example: when choosing an encryption algorithm, choice molecules analyze each algorithm's pros and cons. Anatomy of choice evaluates how the best option is selected. Space of possibility considers all potential encryption methods. Significance: understanding these layers helps in designing smarter systems by addressing small choices, decision processes, and bigger outcomes effectively.